This is Max Stoiber. He is presenting how to scale React.js applications. I didn't have time to read any of his bio because I was presenting the email stuff. All right, I'll give it to you, man.
Thank you.
Thank you.
Welcome everybody. Can you hear me?
No.
I feel like the microphone is on.
Yeah.
He's fiddling with my arm.
Oh, no.
It is on. Oh, there we go. That wasn't React.js. Emails have nothing to do with React.js. Welcome to scaling React.js applications. My name is Max, as you said. You can find me on Twitter at MXSTBR, which is, if you're smart, you've realized that that's my name without vowels. I work as an open source developer at Signal. We're a full stack JavaScript agency, which essentially means we use Node.js on the back end and tons of React and React Native on the web and the mobile respectively. I'm an open source developer, so I work on Keystone.js, which is our Node.js content management system. I work on Elemental UI, which is our React.js UI library that we use to build Keystone. And I'm the creator of React Boilerplate, which is one of the most famous React starter kits with, by now, almost 10,000 stars on GitHub. We released version 3 of this boilerplate a few months ago, and we essentially spent 6 months before then just researching how people build their applications, right? How do developers build their React applications? What do they do? How do they handle files? You know, all these sort of things. And we tried everything, and we compiled sort of a best of into a single boilerplate, React Boilerplate version 3. And today I want to talk about some of the things we learned. This talk has 4 parts. First one is what is scalability, because that's a very important question when you talk about scaling. Second one is state management. Third one, architecture. And the fourth one, performance, because everybody needs performance. So what is scalability? If you take a look at Wikipedia, this is what you're going to get. Scalability is the capability of a system to be enlarged in order to accommodate a growing amount of work. Yeah, I didn't understand that sentence either. Essentially, web apps have to scale in 3 directions. They have to scale to more users, they have to scale to more developers, and they have to scale to more application paths, right? They need to handle that sort of scaling. That term scaling has sort of originally existed in the back-end side of things, right? When you started a new product or something and you had a server with a database on it and you just had a hard drive in there, right? 2 terabyte hard drive, and you just saved, you know, your first dozens of users' data on there. And then as you got more and more users and you go into the dozens or hundreds of users, suddenly you ran out of hard drive space. So what you did is you just put another hard drive in it, right? And then another one, and another one. But then suddenly TechCrunch writes about you and you get millions of users. And you put in hard drives after hard drives and then suddenly your server runs out of physical space. Well, and now what? You can't save any more data. So if your system wasn't designed to be enlarged from the start, to be scalable from the start, you had a problem because you just ran out of space. And this concept, as we moved from rendering everything on the back end to rendering lots of things on the front end, has moved to the front end as well, right? How do we handle more users, more developers, or more application paths on the JavaScript side of things? Let's start off with state management. Todd just mentioned his last talk, Redux is great. This is sort of like a component hierarchy, right? This is what a tiny React app looks like if you imagine each dot is a component. Somewhere down, like somewhere at the very far down, right? Something changes. So what we do in a unidirectional data flow is we go in a non-unidirectional data flow, like Angular 1, you go to your parent, and the parent then goes, and then you go to another component, you say, hey, I've changed. And then those components go to some other components, right? And they all talk to each other, and then something somewhere updates, right? And in the end, you have this huge mess of updates, and you have no idea what's going on, right? So that's what we're trying to avoid with the unidirectional data flow, because this isn't understandable, right? Some input somewhere changes, and your entire page is suddenly green instead of red, and you're like, what? He just emptied his email. Why is everything red? What's going on here? So a unidirectional data flow essentially tries to fix that, right? If we go back to the same thing, we have this change down here. Some input, the user entered his email in this input. What happens is instead of going to the parent component, we go to this separate entity, this third party called a store. And that store, as the name suggests, stores our state. So the store, has a field for an email. And you go, hey, store, I've changed. The input just says, hey, I've changed. Here's the new email that's in my input. And it goes, oh, something's changed. Oh, and it updates the state. And when the state's updated, the store goes to the top level component and it goes, hey, the state's changed. you need to re-render. And then the top level component, well, it's just re-rendered, right? Nothing special going on. And then it re-renders all of its children. And then in the end, we have a fully updated application without any of the confusion of two-way data binding. That, the first idea, the people that gave us this was Facebook with Flux, which was the first implementation. But it wasn't perfect because it relied on JavaScript events. And those were very hard to test, and it was sort of a pain to handle, and you still had these global events going on. It wasn't very nice. So Dan Abram went ahead and created Redux, which is essentially a functional, pure version of Flux, which is much, much nicer. If you're building a React app and you're not using Redux in a big React app, that can work because you can just rely on local component state. But in most cases, Redux will seriously help you get more clarity in your code base, and you can just track the things that are going on because the input says, hey, I've changed, and you can just see in your developer tools, hey, the input said it's changed, and then the store updated, and then this changed, and then the top level component re-rendered, and then everything else re-rendered. And it's really easy to follow as a developer, right? Bugs are really easy to track down. But working with Redux is a bit hard because, as with React, Redux sort of gives you this framework, this library to have the unidirectional data flow, but it doesn't give you any more, right? There's nothing, there's no best practices. So how do we architect a React Redux app? And that's a really interesting question because it's sort of the wild, wild west in the React world, right? Everybody just tries doing something, and if it works, they're like, yeah, this works, okay, we'll just leave it like that. But there is some best practices that have established itself, that have worked out across really big code bases. The first one is containers and components, which is stateful and stateless components, like Todd said. Right? Containers are concerned with how things work, whereas components are concerned with how things look. Right? They're both still React components, just components are React components that have some styles associated with them, they're like a button, but they don't handle any data, whereas containers are React components that are concerned with how things work. So they fetch some data, they format the data, and then they render the right components based on the data they receive. This gives us a lot of, as developers, if my backend developer says, hey, we've changed data format for this and this API endpoint because of this and this reason, I don't need to search through my code base and go, okay, where do I fetch this? Where do I format this? I don't know. Okay, this component, that. No, you're just looking at containers, right? You have these intermediary layers of data management and data formatting in your component hierarchy that allows you to really go in and, the backend API format has changed. Okay, I'll just change the container formatting slightly. If my components, as long as I render the right components, everything will still look the same. And the other way around as well. If your designer comes and says, hey, we've updated the design for the homepage, everything is now green instead of red, you just go into your components and you edit the styles. You don't need to mess around with any data, right? You just go into the styles and change them. And because your containers aren't changed, you're still rendering the same components. If the components look correctly, everything else will work as well. This brings up the question of structure, though. In most examples that you see, like to-do MVC style things, React apps are grouped by type. So they look something like this, right? You have a containers folder, and you have a constants folder, and you have a components folder, and a reducers folder, right? And you have all of these folders. And in our case, we have this navbar container that has a toggle nav action, so you can open and close it on mobile, right? Nothing fancy going on. But let's say I want to change something in that navbar, I have to search through 5 folders to find 5 different files to add a feature, right? That works perfectly fine if you just have one container, right? That's, that works. But as soon as you have hundreds, like dozens already, hundreds of components, that gets really, really tedious because you always have to search for a lot of different files. And you don't know, like, does this container have actions? Does this component have styles? Is this, it's a lot of cognitive overhead. So when we had a huge discussion on the React boilerplate repo about how are we going to structure the files in the third version of the boilerplate. And somebody came in and he said, why don't you group your files by feature instead? Why don't you group all the files related to the navbar in a single folder? And when I first read it, I was like, that sounds like the worst idea I've ever heard. Right? We've been doing this type thing for a long time, it works, why would we need to change? But because I'm the maintainer of the boilerplate, I need to try everything out, even the weirdest ideas are here, right? So I went and I tried it out in like a tiny 15-minute to-do MVC style demo. And after those 15 minutes, I was like, okay, I'm never going to build React apps in a different way again. the development experience of grouping your files by feature is just amazing. So this is what it looks like in your file system. You just have a navbar folder with all the files related to the navbar in the same folder, right? You need to add a feature to the navbar, you just search for one folder, edit all the stuff in there, and that's it, right? You're done. Your code base is a lot cleaner because everything related to that feature, that container, is in the same folder, right? And your different teams can work on different features on different containers without messing with each other, right? They're not even in the same folder. They're just, that team edits that part of the application, the other team that part of the application, right? Everything's really decoupled. This has a few advantages. The probably smallest one is easy renaming and moving. And that, I didn't realize this until I had to rename something in a big code base. I was like, hey, this is actually kind of easy. Because let's say we have this navbar container, right? The same one. And we import some action from there. And now we realize, okay, we don't only need one navbar, we need two navbars, right? So we need a secondary and a primary navbar. And we need to rename our current navbar to primary navbar. Well, in our case, we just have to rename one folder and then do a global search and replace in our code base and replace /navbar/ with /primary nav/. And that's everything you have to do, right? And suddenly you've renamed an entire container. Now, obviously, how often do you rename things, right? That's a tiny side benefit. What's much bigger is that you're just working in a single folder. Everything, like I didn't grasp it when I first heard it, right? But everything related to that container is in the same folder. The amount of time it saves me not searching for files and not having to think about, okay, the navbar, does that even have actions? Let's look at the action folders. Okay, maybe somebody called it just bar actions or just nav actions, you know? How does that work? I just look into the folder and I see, okay, this has a toggle nav action, and that's it. You get a lot more reusable components because you can take that folder and you can push it up to npm, right? And if your company has multiple apps, you can just npm install my company/navbar and just reuse it, and that's it, right? Because all the files related to that container are in the same folder, it's easy as pie. So I tried this, and then I went, well, that's very nice and all, but what about styling, right? In a component-based system, CSS is kind of not made for a component-based system, right? We have a global namespace. So we get naming conflicts. So if we have two components, a header and a footer, and both have a subtitle class, well, now our title suddenly has a background color of yellow and a border color of blue, neither of which we actually want, right? So this is kind of annoying. Because in a component-based architecture, you're going to have a styles file for every component. Those global, global conflicts are pretty common. I've stumbled upon these bugs a lot of times. There's some naming conventions that solve this, right? Like BEM is probably the most famous one. The problem is with BEM, you're giving your entire global namespace to developers. You're giving the entire control to humans. And I don't mean to insult the developers, right? Not at all. But we are the ones that mess programs up, right? If programmers didn't exist and programs just existed without anybody programming them, they would be perfect, right? Every bug you've ever found in a program is there because somebody programmed it like this. So these bugs, they still happen, even with BEM notation. Maybe not because you mess it up, but because one of your hundreds of developers in the same team messes it up, right? He doesn't check that the name already exists. He uses SAS nesting, so looking for duplicate names is really hard. And then you're trying to find, okay, why is my title, why does it even have a yellow back? That doesn't make any sense. What's happening here? So let's let computers do it for us. Why are we doing it if computers can do it so much better? That's essentially the short version of how CSS modules work, right? This is what it looks like. We import styles from the component-specific styles file, and then assign a class name of styles.footer. And this styles.footer, we can define our styles.css file for our footer component, right? And what CSS modules does is it goes ahead and it takes that class name and it makes it completely unique. So whereas previously we had a global.footer class, now we have a class called .myApp __footer __, and then some random hash that's based on the contents of the class. That means even if I have the exact same class in another file, it won't have the same name. Because the hash is based on the contents of the class, if two classes are called the same thing, they'll have different hashes if they have different contents. And if they have the same contents and they have the same hash, they have the same contents anyway, so overlap doesn't matter, right? Because the styles are the exact same. So suddenly, without us having to think about it, without me as a developer having to go, okay, does this name exist? No. Am I sure? Okay, so that's nesting. you just write generic class names, right? You don't have to worry about underscores, you don't have to worry about anything, you just write generic class names and there's never going to be any overlap. A second problem with CSS in a component-based architecture is inheritance, right? About a dozen or so properties in CSS inherit from parents to children. And that's very nice, right? That's a nice feature of CSS that we have that. The problem is that sometimes it leads to problems, right? If we have a title component or a button component, and we want that button to look the same no matter where on the page it is, right? And suddenly the parent component defines a line height, our button's line height is going to change because line height inherits to children. And you have a button component and you put it in the footer, and it looks different from when you put it in the header. That's really weird. Like, you don't want that. So we get these conflicts. Now in CSS, we have this concept of a global CSS reset, right? Something like normalized.css or sanitized.css or things like these, right? So what if we had a component-based reset? What if every component was reset so there was no inheritance anymore? Now the thing is, this doesn't mean that there's no inheritance at all, right? People sometimes mistake me saying this for there is absolutely no inheritance whatsoever. The difference is that if we have a local reset, we can still say line height inherits, and it will still inherit if we want that. For example, if we have some sort of paragraph component, right? We want the line height to be the same as in the parent, right? We want that to be inherited. But we don't want anything else to be inherited. So we say specifically, just inherit the line height. It's inheritance opting in, not opting out of inheritance, right? It's a much nicer developer experience because you have a component, and they just look the same wherever they are, right? You can reuse your components across your entire app, and they always look the exact same way, except when you want to inherit certain properties. So that's possible with PostCSS, which is a modular CSS preprocessor, and PostCSS auto reset. What that does essentially is it sets all inheritable properties to default, which will just set it to whatever the default value is, and there won't be any inheritance anymore. There is a CSS spec to make this even easier, which is called all initial, right? The problem is it's not supported in most browsers yet, so you have to polyfill it like this. Now that we have sort of like, you know, our styles for our components, and we have no inheritance anymore, we can just take that specific component CSS file and put it right next to the component, right? We don't need a CSS folder anymore. Some of you might be thinking, but what about global styles? Where do I put global styles? Think about what global styles do you actually have. You have a CSS reset, which you probably install from npm or bower. And then what? You might say something like global typography, right? But instead of having global typography, have components. Have a heading component that has a level property that you can set, and you can adapt the styles based on that, right? You don't need global typography in a component-based system because you should be working with components anyway. They're much more powerful than just using CSS classes. So now we've achieved true component isolation, and now you can really take that folder and push it up to npm, and you can npm install my_company/navbar, and you're going to get not only the navbar behavior, but also navbar styles in the exact, like with one single command, which is very, very nice. So now you have these containers in the components, and you use CSS modules to isolate your styling, and blah, 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 blah. The missing link for me was TakesAttention. Because in a Redux-based thing, what we usually do is we use Redux Spank. Redux Spank allows you to dispatch actions, and they allow you to asynchronously do something and then dispatch some more actions, right? So you can have a fetch data action that just fetches some data, and then based on what comes back, dispatches some new actions. The problem is that you end up with these huge functions in your actions where it's just like a huge fetch data action that does a bunch of asynchronous stuff. It's not testable at all because it's a func, so you need to inject dispatch and then you need to inject fetch, and it's just a pain to handle, right? It's not nice. Now before I go on about data fetching, I want to talk about an example. Imagine you have a clock component and a timer component, right? And the clock has a start button that when pressed will start the timer, and the timer will have a stop button that when pressed will show the time on the clock, right? So what you normally do is something like this. You go on start, click, dispatch, start timer. And from the timer you go on stop, click, dispatch, start clock. Now that works, right? That's perfectly fine. The problem is that you have these really decoupled components, and now you're tying them back together, right? You cannot reuse this component anywhere because now it relies on the timer existing. You cannot just use the clock, or you cannot just use the timer. You have to use both. What if some app just wants the clock? So there's this new idea that has come up that aims to solve not only the data fetching, but also these issues to get truly decoupled components, and it's called React Saga. React Saga is, Sagas are like a separate thread in your application. That's my mental model when working with them. They aren't really, because JavaScript is single thread, right? No way around it. But they sort of act as a separate thread, right? So you have your main application thread, and you go, okay, that renders some stuff, and it calculates some stuff, and it does something with the data. And then you have your Saga, and the Sagas just don't do anything, right? They don't do anything. But then your action, your main application thread, dispatches some Redux action, right? And Redux Saga goes, oh hey, an action has happened. Oh, something asynchronous needs to happen, like fetching data. Oh, I'll fetch the data. But your main application thread, yeah, right? All of your actions and reducers, they don't have to care about that, right? You've just dispatched an action, and that's it, right? And Redux Saga does all the asynchronous stuff, it does the data fetching and everything. And then when that's finished, it'll just dispatch an action back again, right? And it'll say, hey, the data's there. And your main application goes, oh, data's here. Oh, I'll just re-render. And then everything re-renders. So it's sort of, my mental model when working with Sagas is sort of like a separate thread that just communicates with my main app thread via Redux actions. So if we go back to our clock and timer example, instead of dispatching specific actions, we just say, hey, the clock when start was clicked, let's just dispatch a start clicked action, right? And from the timer we say, when a stop button is clicked, let's just dispatch a stop clicked action. And that's it. And then we use Sagas to tie them together. Now, before I go on to the next slide, this is ES6 Generator syntax, right? If you've never seen it before, it might look a bit weird, but bear with me while I explain it. So what you see here is a function asterisk keyword, which marks this as a generator. And then we have a while true loop. That's an infinite loop, right? That's just going to crash. Well, not quite, because contrary to any other JavaScript function, generators, the function asterisk thing, they don't execute until the very end, right? They have this yield keyword, and the generator goes in when it's called. It just goes, oh, I'm called. Okay, I'll execute. Oh, there's a yield keyword. I'll just stop, and it stops, right? And it doesn't execute on. And what we see here on the right side is a Redux Saga specific thing called take, and take allows you to wait until an action happens. So this generator goes and executes, and then it reaches the yield, and then it goes, okay, I'm not executing anymore. I'm waiting until the promise on the right side resolves. And then as soon as its start button clicked action comes in, Redux Saga goes and says, hey generator, you need to start again. This is your thing, right? We're back. And the generator goes, oh, I'm executing again. And then it executes again. And what it does is it dispatches a start timer action. And then it waits again, because nothing happens, right? We've started the timer. And then we again have this take thing, and this time we wait for the stop button click action, right? So the generator doesn't execute, it just waits, and then sometime the user might press the stop button. And then when he does it, that Redux Saga goes and says, hey generator, go on, it's happened. And the generator goes, oh, I can execute. And then it dispatches the stop timer action and the show time on clock action. And that's why the while true loop is important, because if we didn't have the while true loop here, what would happen is the generator would reach the end of the function and then it'd be over. Right? The generator wouldn't run anymore. So the next time the user would press on start, nothing would happen because nobody's listening to the start button clicked action. But because we have the while true loop, the generator now goes, oh yeah, I have a while true loop, so I'll just go back to the top and reaches the yield keyword of this start button clicked action again and stops executing until the next start button clicked action comes in. So what we have here is we have really, really decoupled components, right? We not only have decoupled the styling and the behavior, we've also decoupled everything, right? This clock and timer component can be used completely independently. The clock doesn't care what happens when the start button is pressed, right? And the timer doesn't care what happens when the stop button is pressed, right? They shouldn't have to, because you should be able to just use the clock and start something entirely different. So now you can combine them together, or you can combine entirely different components together, right? They're really, really decoupled. So let's sum up this sort of rather long section. The first thing I talked about was containers and components. Right? Containers are concerned with how things work. Components are concerned with how things look. Group your files by feature to just work from a single folder. Isolate the styling with processes auto reset and CSS modules. And then use React Saga to tie your really decoupled components back together. So let's talk about performance. Many people, I think, in the JavaScript world sometimes forget that performance is a thing. Right? They're running the Reactor on a local machine, and everything's really fast because they use a very new iMac with fucking shit ton load of RAM and a really fast processor and everything, right? But your average user is not going to sit on a brand new iMac with loads of RAM, right? He's going to sit on some Android phone trying to visit his bank profile or something, and it's just going to take ages. So with this bundler called Webpack, which you should be using, they have this feature called code splitting. Code splitting essentially determines which parts of your app are used on which route, right? So you have your about page or your profile page. And Webpack sees, okay, on the profile page, you're using React, and you're using the avatar component, and you're using a list component. All right, so when the about route is requested, Webpack just sends down the data for that one specific route, right? Nothing else goes down. It's kind of like an HTML file, except you don't have to think about it in different files. So Webpack goes and bundles all of the about things into the into the about bundle. And then when a user goes to the about page, all he gets is the about bundle, not more and not less. Whereas before, without code splitting, if you have a home page and an about page and a, you know, what do I know, what do banks even do? And a purchases page and whatever. And the user visits any of these pages, he just gets all of the data, right? They just get everything. But with code splitting, they just get exactly the thing they want. Now, I would love to show you code here, but code splitting is currently being entirely reworked, right? We're almost done with Webpack 2, so the code is entirely different. So I won't show any code today, but you can look it up. There's a great guide by Eddie Osmani. But there's a second type of performance that's also really important, which is runtime performance, right? No matter how fast your bundle loads, if your app is really, really slow, it doesn't help you because it's really, really slow. Now, React does this thing where it re-renders the entire application on every single tick, right? So again, something changes down there in our component hierarchy. And what happens is, you know, we go to the store, and the store updates the state, and blah, 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 and then we go to the top-level component, and we tell the top-level component to re-render, right? So the top-level component re-renders, and then its children re-render, and then their children re-render, and then their children re-render. And then we've re-rendered everything. And that works for, like, small applications, right? Because React has the virtual DOM, where it just re-renders a virtual representation of the DOM, and only actually inserts the changes into the DOM, it's quite fast. But the problem is in big applications, that still becomes a performance bottleneck. Because you kind of only want to re-render that part, right? You don't care about all these other components don't care about that input down there, right? They don't care about what that input has, right? They shouldn't have to re-render because of that. So React has this lifecycle called should component update, which tells React this component should update or should not update. In our case, we want to have this component up there say, okay, I don't want to update. I don't care about that whatever the user input down there is. Right? I don't re-render it. None of my children should re-render either. The same thing for this component and for that component. The thing is, the biggest performance impact is at the very top. If we can bail out very, very high up in our component hierarchy, we can essentially just skip half of the application re-rendering with one should component update, right? Whereas that component all the way down there is just one component not re-rendering, right? Not a big deal. But that component up there not re-rendering is a big deal. So what we want to do in this should component update function is we want to kind of return next props does not equals this dot props, right? That's kind of what we want to do. We want to say, hey, if my properties haven't changed, what do I care? Just like re-render all the other stuff. Like I don't just re-render. The problem is JavaScript, as always. Because in JavaScript, if you have two objects that have the same content, they're not the same. You cannot compare them. And the thing is, so what you could do in this case, right, in this very simple case, is you could go in and you could loop over every property and value, in this case just username, and say, hey, is the username on the left side the same as the username on the right side? Okay, that works. But the problem is we're trying to bail out really, really high up in the component hierarchy, right? We're trying to not re-render half of our application. And up there, the properties that we have to compare, the property tree is a lot bigger, right? We don't just have a username. We have a list of things, and then we have an array with nested objects, with nested arrays, with nested objects. And comparing all of that is really, really expensive, right? You can do it. You can compare two objects really deeply, but it's really expensive, and it's going to make your application even slower, right? It won't give you any performance benefit. So we use Immutable.js, which gives you an immutable data structure. Why is that cool? Well, let's take a look. We do this thing called from.js, and then we pass in whatever data we want, right? And we import that from.js from Immutable. And we pass in our case, an object with username at NXSDBR. This state variable over there is now no longer an object. It's an immutable, in this case a map, I think. So it's some sort of representation of an object. But the thing is, you can never update this. If you want to go state.username equals a.model, Immutable.js just throws an error, right? It just goes, wait, this is immutable. You cannot mutate immutable objects. And that makes sense, right? And the nice thing about that is, because we do this from JS code, because that object can never, ever change again. What Immutable.js can do is it can generate a hash based on the contents of the object, right? So it can go through an entire object and hash the entire content and save that hash in some private, field. So now you have a hash of the contents of that object that can never change, right? And then you have two of these objects. They are entirely different objects, right? But you can do .equals. And Immutable.js will go, and instead of comparing every single property and value of that object, all it has to do is compare two hashes, right? Because you have the two hashes that are just a string, essentially deeply comparing objects is now as fast and as cheap as comparing two strings. So now bailing up really, really high up in our component hierarchy is no longer performance intensive because we're just comparing two strings. So now we can really do what we wanted to do previously, which is if something down there changes, we re-render, and then that component just bails out and says, hey, no, I don't care about this, I don't want to re-render. And then the next one says, no, I don't care about that input down there, just don't re-render. And then we've just re-rendered exactly the part that we want. All right, so short summary, all right? We talked about what is scalability. Scalability means your application is able to handle more users, more developers, or more application calls, right? Those are the three things we care about. The second one was state management. Use a unidirectional data flow library. Specifically, Redux is very, very good. Then we talked about architecture, which we covered previously, containers and components, group the files by feature, isolate your styling, and use Redux Saga to get really, really decoupled components that you tie back together. And then we talked about performance. Use Webpack, use code splitting to only send down the parts of your application that your user cares about, and then use Immutable.js to get deep updates and deep shoot component updates really, really cheaply. Thank you very much. Enjoy the rest.
Thank you, Max. Amazingly, we have all the time in the world for questions, apparently. We have like 10 minutes. You were the fastest speaker. Congratulations. Nice. You win a prize. Oh, come see me. I'll give you an eclair. Okay. All right. Anybody have any questions? Oh, there we go. That gentleman over there.
Really wants to ask a question.
Gentleman in quotes. Yes.
I need the mic.
God damn it.
I'll just repeat the question.
All right. I'll get the other mic.
Hello, awesome presentation, thank you very much for that. I would like you to dive a little deeper into how CSS works in terms of the global, like you said, global typography. How will there be any repetition in redefining H1s, H2s, H3s? And how much overhead the local reset CSS brings to the project?
So, there's two questions there. I'll answer the first one. So the thing about Reactors, right? We have components. And imagine something like an image tag, right? You have an image tag and you say source equals something. I'll just use image as an example because it's quite a good example. And you could just use image tags, right? You wouldn't need to have an image component. But because we have JavaScript and because we use React, we can have a prop type on that image saying alt is a string that's required. And suddenly none of your developers can go in and have an image without an alt tag anymore, right? Which you want because otherwise it's not accessible at all. So by using components to our advantage, we can a lot better than just with raw CSS, we can enforce certain things and have more logic in there than we had previously. Does that make sense? Does that kind of answer the question? No?
I need to understand because you said do not use global typography CSS.
Yeah, the same thing applies to heading, right? So instead of having an H1 tag, you can have a heading component that has certain logic in it, depending on whatever your app needs, right? And you can have a lot more complex logic in there. And it's not any bigger overhead, because you're just importing an H1 component that just renders an H1 tag with certain styles, right? But contrary to before, those styles are completely isolated, and your app can enforce certain things like titles have to be between 80 characters and 160 characters or whatever, right? Does Doesn't matter. Whatever requirements React has, you can enforce them in JavaScript, which you couldn't really in CSS before.
Excuse me, are you suggesting that we should redefine the H1's height, font, weight, etc. on every component?
How do you mean, sorry?
H1 has some properties, but
Yeah,
font
you can
type,
pass them
font
on.
size,
Yeah.
line height, do we redefine those?
No, because your H1 component renders an H1 tag, right? It doesn't render a div or anything. It renders an H1 tag, an HTML tag.
H1 is going to be a component itself.
Yes. So you have an H1 component and you have an H2 component.
All elements of...
Yeah, I really find that most things, like for example a button, right? With a button, if you have a button component, sometimes that button should link to an internal page, which you have in client-side routing. That's the use case that I've had 1,000 times, right? So you have a button, and it sometimes links to an internal page, which is used with React Router, so it shouldn't, open an entirely new page. But sometimes that button links to an external page, and it needs to open a new tab. So what I can do with the button component is I can either render an actual button element or I can render an anchor tag. And depending on if there's an href or a 2, which is the React Router notation, I can either render a button that just uses React Router to redirect to a new internal page, or I can render an anchor tag that's an actual link to redirect to a separate external page. So I do, in my React applications, redefine most HTML elements that I need. I don't redefine div because it's just a box. Why do I need to redefine that? But things like button and headings, they're much better. Like, we have the power of JavaScript in components. Why shouldn't we use it?
Anybody else have a question?
The local reset overhead?
Oh yeah, sorry, the local reset overhead. Yes, that's a very good question. So the thing is, if you just use it in a non-CSS modules application, what's going to happen is that every component will get 12 lines of code, which in a big application is quite a bit of overhead, right? Because you have maybe hundreds of components, you get 12 declarations. That's a lot of code that you're sending down that shouldn't have, doesn't need to be there. But with CSS modules, what you have is this composes property. CSS modules can compose multiple class names. So you can have a class that resets it, and then you just compose every component from that class. And the only thing that happens is that there is a tiny 2-character class on every component, right? So it's 20 lines of code more, essentially. So the overhead, if done right, isn't very big. The overhead, if done wrong, is very big.
All right. Anybody else have a question? Okay, well, thank you very much, Max.
Thank you.
And thank you for being online with us. Okay, now I'm going to announce the winners of the contest that we had. So, no, you're not. You didn't win anything. I can tell you right now. Okay. Well, we hope you've enjoyed your free beer, which Interworks Cloud offered, and that you had the chance to meet them. They are the guys who have the cloud, and you can take pictures with them and stuff. So now, I'm going to announce the winners. So, the winner of the 6-month OneDrive plan subscription is Apostolos Economou. Do we have an Apostolos Economou here? No, okay, all right. He's lost then. He didn't win anything. The Office 365 Business Premium for 6 months is Δημήτριος Καλετζάρης. Άμα το λέω σωστά. Δημήτριος Καλετζάρης. Όχι. Και αυτός δεν κέρδισε τίποτα. And, okay. The winner for his own Interworks Cloud Virtual Machine, Marianos Gougouras. Υπάρχει κάποιος? Κανένας δεν ήρθε στο web σήμερα, τι να σας πω. Nobody wins anything, yeah. No. There's a guy who wins a Lumia. Yeah, Lumia 550, which is a pretty good gift actually. Alright, Michalis Tsikas. Is there a Michalis Tsikas in here? Τίποτα, παιδιά, nobody wins anything. Good day, sir. And well, I would say something to the winners, but there are no winners here. Congratulations to the guys who didn't win anything, you losers. Big applause to yourself.